Hello. Before I start, I would like to ask why this is not working. That's my first question. There you go. I would like to ask who has heard or is working with serverless stuff. Tough crowd. It will be a tough crowd. So serverless, it's this new concept. There you go. We go from a traditional architecture where we have the user with the browser sending requests to a server where it renders all the front-end parts. And inside that box is all the front-end, all the server-side logic, and all the interactions with database and other services. This is what we had until a few years ago. What is serverless? It's server-side logic written by developers. So instead of having everything in the box, runs on stateless containers that are event-triggered. So they can be triggered by API gateways requests, cron jobs, database streamings, everything. There are ephemeral, so they are short-lived. Usually, we have a 5 minutes life for each container, which, for instance, AWS is increasing to 15 now. And it's fully managed by a third party. So it removes all that management from that single box into a third party. And this is an event-driven application in a traditional architecture. So imagine this server part can be an EC2 instance in the cloud, but still it's kind of a traditional architecture. In this case, the user will click something in the browser, will go through the message channel, process something, and will update the database. Yeah, pretty much traditional. So, introducing functions as a service. Functions as a service is a category of cloud computing services that provide a platform allowing customers to develop, run, and manage applications functionalities without the complexity of building and maintaining the infrastructure. So this is the description on Wikipedia. We all love Wikipedia. What does this mean? So, for instance, the main benefit, it's inside the description text without the complexity of building and maintaining the infrastructure. So this, for us developers, is awesome. We don't have to worry about that. Functions as a service, they do not, so you can code in any kind of language, the best one for the job you are trying to do. It's not tied to a specific framework or library or anything. So you have several first tenant languages in each vendor. You can choose whichever you like. These functions are unique tasks, so they do one thing and one thing only. And they are stateless, so you cannot count. Because they are short-lived, you cannot count with keeping a state and go and use it further on your app. Deployments get simpler because you're just deploying one single function. And then you can use also versioning, one of the big benefits. Horizontal scaling of these functions is automatic. So scales automatically according to the number of requests you have. And also, they are triggered by event type. So if the user goes to a page or clicks something that calls the function as a service, if you have 1 million users clicking that link or that button, it scales automatically horizontally, and no worries for us. Some drawbacks that I would like to introduce. So granularity. Usually, we developers tend to go very granular in our code, so this doesn't mean that a function to check if the number is odd or even will be a lambda. Don't go that way. it will be a hell to manage all your functions. They are stateless, so meaning, for instance, saving the user session, you cannot save it in the state of the container. So you will have to use a database, some caching like cross-platform, cross-application Redis, or even object store like S3 or some other CDN. Again, short execution time. For instance, in this case, AWS increased from 5 to 15 minutes. So this will mitigate the cold starts, which is a big issue, especially depending on the language you choose to code. Some languages, for instance, the compiled ones, have cold starts of 5 seconds or more. So that's a big drawback. However, vendors are working on this, so expect some big improvements. I think it's this one. Yes. So our previous architecture now using functions as a service. So we've isolated, I have a pointer, the server part, so the EC2 instance in the cloud, now only contains the message channel. We passed all the functions, so the click processor, and you can see it scales so automatically, and then it goes to the database and does whatever you want it to do. So from here, now this is still on the server side. Let's take care of this, and for that, there's this new concept, or not that new, but API gateway. Do not get confused. I'm not talking about the AWS one, which is called API gateway, but you can do this in any other vendor with any other, it can even be a Lambda function or a function. So this is what is called the backend as a service. So the requests go to this backend, and then from then on, it goes to the functions as a service. Usually they are considered HTTP server, so that's where your endpoints, API endpoints live on. Allows mapping, and this is a little bit more related with the AWS API gateway. It allows mapping from an HTTP request body object to create a model to then send to the Lambda function. And also the other way around. So when we have a response from the function, you have an object, you can use a model and map it to the HTTP response. One really interesting thing is you can add authentication. So if your API needs API key or a user token, it can validate that. Also invalidate the input, the data you're sending, and the response codes mapping. So when it can send back a 200 or a 403 or 1 and all that stuff. So all of that is done on the API gateway. So the main benefits is security validation before calling the function as a service. Validates the request parameters, and nowadays more and more we are seeing regional endpoints. So if the request comes from Europe, it can be redirected for any server in Europe instead of going to US or something. And you can also configure several environments, so you can mimic your development environment. So developing, staging, and production, and you can test all of that. So you can do the integration tests and all of that. There is one thing that I forgot to mention. On the functions as a service, of course, the main benefit is costs. So you only pay for what you use, instead of paying for a 24/7 on server or an EC2 instance or a data center or something. And that, so this API gateway, because it validates a lot of stuff, or can validate a lot of stuff before calling the function, it also gets a little bit cheaper. And this is now our architecture using a serverless architecture. So all inside a cloud can be one vendor, two vendors, you decide. I do suggest one vendor. You have the API gateway where you have your API endpoints that you call from the front end. These API points fire events that will then run a function as a service, and that function as a service can just go to the database or do whatever it does, like processing images, sending emails, whatever you are doing. Other services that can also be used with function as a service. Databases. So as I said before, for instance, DynamoDB on AWS can fire streaming events. You can take those streams and run a function with that. Also, what can be done is, instead of having a monolith database, you can also split it into several databases. I do, at this point, have to apologize for my handwriting, but this is products database, and for instance, this is a reviews database. You can decouple those and work singularly. So this is get product reviews, list products, create products. So all of these are singular functions, separate ones, and yeah, they can interact with as many databases as possible. Also, another good thing is notifications. So you can use a notification service like SNS on AWS, and the function can ask to fire an event, and any other function that is listening to that event will run. So for instance, as an example, the user deletes an account, hopefully not that much, but delete account, you go to the database, you put status as deleted, and then you fire a notification, and you have, for instance, delete user images, anonymized billing, user billing, so you can have a bunch of other functions running, and the user doesn't need to be waiting for that to finish. And queuing, for instance, if you have, when a user registers on your website, you want to send an email, you can use a queuing to process all the emails synchronously, so in an order. But hold on, I've been talking for quite a few times, the time is off. What about the front end? So all of this is considered, or all of this is considered back end. What about the front end? The front end is still on the server. It can be on an, again, EC2 instance, generating the HTML. What can we do about it? So we can create a static website. We can host it on an object store, which is basically an HTML file with some JavaScript files. The HTML calls the JavaScript and runs everything. So it is a static, can be considered a static website. And we can use client-side frameworks like React, Angular, many others out there, the ones you prefer. I'm a really advocate for React. I really liked working with it. So, so you create a static website, you host it on a cloud storage, you configure a CDN so you can have caching, and then that same website, or the front-end part, the client-side site, you can integrate directly with the API gateway to make requests of data or send data, and you can integrate with a GraphQL, which is something that I'm really enjoying lately to working with. Also taking benefits of caching on the server side, since GraphQL can be considered server side. So this is what we can do to our front end. What do we benefit with that? So we have modularized code. So, and for instance, if you use React, you can create very small modules, specific modules, where you have your JavaScript, HTML, and CSS just for that module. You can, on the CSS part, use a bunch of libraries. I do prefer to use a BEM structure of the CSS classes, so it guarantees or mitigates the clashing of CSS classes. For instance, the button can have a wrapper, and the header can have a wrapper, and everything is okay because the component name is there. Development time, it is much, much faster because you are just developing small modules, very contained ones. What can also be done is code splitting. So when bundling everything to send to the S3 to be hosted there, all the code can be split, so you don't need a huge JavaScript file. You can have modules per pages, even components. So you can put the header as an asynchronous component. Webpack, if you use Webpack, can process all that and create different JavaScript files, much smaller files. One of the advantages, also going a little bit back, of putting on a store, an object store, is the fact that they have HTTP2 configured. So this code splitting into several files, I mean, you can take advantage of that. You can add also an application state management. I like Redux. It will help to keep the information on the client side and reduce the amount of calls done to the server to request the same information. So if you have a shopping basket, you have the list of products, you click in product A, you go to the product details, you can go back and forth, and you don't have any other call done to the server. Another big benefit is the amount of frameworks existing today. So I talked about two, React and Angular. There are a bunch of others. You have SDKs that can help connect the front end to the server side to consume or to send requests to the API, or, using the GraphQL. And also, I think a huge amount of libraries to be used on the front end. If you go to NPM and filter by JavaScript libraries, you'll be surprised. Also the deployment pipeline, so from development to testing to acceptance by the stakeholders to production can be defined. And so you can also have several environments, like you can configure object storage for dev, staging, and production, and you can keep testing and all that. Some drawbacks, SEO, big thing, I would say, depending on your project. But nowadays, there are a few things that can be used. One of them is the HTML5 push state API, and also already, if you have some inline JavaScript on your HTML5, the search crawlers will see that, and it will wait a few seconds until you get the results, so they can then index all those results. So. And another drawback is exactly the usage of external libraries. So it is very easy to go to NPM, search for something, import into the project. The fact is, it will have to be minified, go to a bundle, and then parsed. And then at the end, you have the main bundle taking 2 megabytes initially to download and to run the site. Bear in mind, all of that will have to be parsed, so it will take time. So I'm a little bit, yes, use libraries, but please do have a balance. Some things takes you half an hour to make, and you don't need to bring one library that is dependent on other libraries. Oh, look at that. So this is now the front end lives here on an S3 bucket. So let's put kind of a separation here. This is the S3 bucket. I do have to say I forgot to put here on this level a CDN, which you can easily configure to access the bucket. I say S3 and I talk about AWS because that's what I usually work daily. So the user gets the site from here. One good thing about separating all these concerns is we can use third-party authentication services, so we don't have to manage those. Also, nothing stops you from having your own function as a service here to a user's database. Then the user, when interacting, can interact directly with the API gateway with its endpoints, or my preferable, go to a GraphQL where you can query, and the GraphQL then aligns with the API gateway, but caches the data here, and it's much faster. And one really cool thing that I see a big benefit is subscribe to events done through mutations, which allows you to have real-time data on your website. So user A has a shopping basket, changes the quantity of products on product A from 1 to 2, and on the mobile device, if it is open, it is subscribed to the mutation of the quantity of the product. It will be automatically updated there, so you don't have a shopping cart on your mobile phone and a different shopping cart on your desktop. That's one thing. You can use this to create chat tools also. It's very quick. You just mutate, save a new chat line, and everybody subscribing will get that chat line. Bear in mind that this and this is all scalable automatically. So we developers do not need to worry about any kind of scaling. Even the S3, this is just a CDN, so it's very, very scalable. So you can have 10 users or 100 users or 1,000 users or 1,000,000 users, and this will scale. This, I mean all this. All this solution will scale. So, why go serverless? We all know there are drawbacks. One that I hear a lot is vendor locking. It is true, but nothing stops you from having, for instance, this part here on a different vendor. For instance, separating your functions as a services and your API gateways per vendor, if you go that way. I honestly don't mind vendor locking, but if it is a concern for your product, your company, there are 5, 6 vendors, big players in the market, like Google, IBM, AWS, Microsoft, and some others, which are kind of getting traction. So you can do that. I think you will end up in a hell to maintain all that. Security, meaning going back here, going back here, you need to create some security for the functions to interact between each other. Also, security here on your object store, on your CDN. So this, for me, being working in this type of architecture for almost a year, I find it somehow difficult to create and define the policies of each service to interact with each other service. So for me, that's a big drawback. Repetition of logic across client-side platforms. Sorry for that. If you have a website, if you have a mobile app, you will have to duplicate the code for the list, but it will go through the same channels. Those channels will not change. So for some companies, they prefer to have a responsive website. I mean, it's up to you, but this can be a big drawback. Again, cold starts. I hear a lot about cold starts, and it's the main concern from the developers I know. For me, it's not. There are several ways to mitigate it by choosing the language most proficient for the task you're doing. for instance, to list products, just go to a database and return a list of products. You don't need to do it in Java. Java takes time to compile, or .NET, which uses almost the allowed space for the code in a Lambda function. You can do that in plain JavaScript with 10 lines of code. But yes, they do exist. Vendors are working on those. Cloudflare is very actively working on a structure. Instead of containers, they have even smaller things. I haven't dug that deep into it. Monitor and observability, it is definitely a big drawback. Vendors don't have tools to help that much with this, so we must rely on, again, third parties that will monitor your servers, monitor your functions and all that. Regarding the implementation and all that, regarding the implementation drawbacks, vendors didn't have that many options configuration-wise. So if you wanted to configure a function as a service, you didn't have that many options to optimize it. They have been working really hard on this. These two are intertwined, meaning if you have an account on a vendor, usually you have a limit of invocations that you can make. If you're doing load testing, you can reach that limit very fast, and then your production site gets DOS because you reach the limit of the invocations. And debugging is not that easy either, mainly because you're dependent on third parties. However, I see a lot of benefit. Well, these are the main benefits for me. And so the first one, if you want to sell it to your company, reduce operation costs. These will actually be cut. We'll have 60 to 70% cut on my user experience on the company I'm working. So it's a big deal. Reduce the development time, so time to market, because you are creating singular things. It's easier, it's faster to create. So development time will be much faster, and the time to market from idealizing and then implementing the back end and the front end will be much faster. Simpler packaging and deployment. So because we are deploying specific things, small things, they are much faster. For instance, from the traditional, just a side note, from the traditional architecture to the serverless one, this one, the functions as a service, people are migrating through microservices. However, if you have a client microservice, if you want to deploy a bug fix or a new feature on the create client, you will have to deploy all the services because they are all there. So functions as a service, you can just fix the create or implement something on the create client, and you just deploy that one. You don't need to deploy your whole solution. This automatic horizontal scaling, for me, it's one of the main benefits. So this allows you to have not to worry about the amount of people that access your product or your application. For instance, as well as I had last weekend with Black Friday, where we had to go to the office. With this, you just let it scale and let the boss worry about the costs. Server optimizations. So a lot of the logic that on the traditional architecture is done by the client side can go to the server side, as well as some logic that currently exists on the server side, like validating authentication, input validations. You don't need to have that on the server side. You can put some on the client side or someone in the between with the API gateway and the GraphQL. And easier operations management, because basically you don't need to manage the infrastructure. So the vendor will do that for you. You don't need to worry about what's installed on your instances or anything. You don't need to worry, no, I have 2 instances running, I will need to put one more up. It scales automatically, so this part is also big. Future. So mitigating the drawbacks. There is quite some tooling being developed right now to help, not only by the vendors, but even with third parties, to help debug and monitoring your application. Some vendors are talking about adding state management to their function as a service containers. Platform improvements, so that's something that vendors are working every day. And education of developers. So I think, in my opinion, this serverless structure will make us rethink how we create applications. Instead of creating one big thing, no, we will chop it into smaller bits, and then they will have to communicate between themselves. I think this is a big thing. It will be fun to see some emergent patterns on developers. So with all of this, with this new way of thinking and all that, we will start see developings doing something. So for instance, one of them is the Lambda Edge, which is putting a Lambda on top of the CDN and then decide which bucket to use, for instance. Instead of using the API gateway, is using a Lambda function that will serve as your router, for instance. That's also another emergence pattern. It will be fun to see where things go. Testing. I think this will also make us developers rethink a little bit the way we test. I've heard some people saying, hey, 100% of my code is tested. Cool. That doesn't say much. I think we need to think what we actually need to test, what brings value to us. Sorry for the testers in the room. But so this will allow us, for instance, for the front-end side, since we are creating very small modules, we can add tests in there, kind of unit tests to your UI components. If you have a container with several modules inside, components inside, you can do the test for integration tests, and when you have the page, you can do the end-to-end, or, I mean, we will need to think about that a little bit, maybe reduce the amount of unit tests, increase a little bit the end-to-end tests, maybe. I don't have a strong opinion in there. And the community. The community is growing. There are more people joining the serverless structures. When I say serverless, for me, it's with the function as a service structure. And the community is growing. A lot of ideas are coming out. A lot of people are coming with the tooling, for instance, and the monitoring services. So that's nice to see. Yeah, I think, thank you. And now the questions, if any. Sorry, I don't know if I was went too much into detail. Any questions? Come on, sir, you asked questions for Don't be shy now. I'm kidding.
Excuse me.
Yep.
I find hard to reconcile two topics that you mentioned. One is automatic horizontal rescaling.
Scaling, yeah.
With the risk of self-DOS by testing and debugging.
Yes. So And this is more from the AWS vendor. So you have a limit of requests that you can make for a Lambda function. Depending on the amount of load tests you do, if you test with 1 million users per minute, you may reach the limit of invocations that you can have on your vendor, and that will bring a 404 for the production. Meaning, if you have an account where you have configured your development, your staging, and your production, the limit is crossed to all those environments. So if on the staging one where you're doing load testing, if you reach that limit, the ones that try to access production, they will get a 404. And that's the DDoS. To be honest, I've never faced or seen or heard about a scenario like this, but it is possible. Since there are limits, it is possible. And the other part was just that one? Oh, the horizontal scaling. Yeah? Please, the microphone. Yep.
It seems like a conflict of concepts, because what's the difference when I do debugging in testing and sending 1 million requests per minute? It is doing that, but it's 1 million of real users doing it.
Yeah.
And the scaling solves the second situation and stucks in the first.
Yes. So the scaling is I'm saying 1 million. I don't think the limit is 1 million, to be honest. So if you have 1 million, the functions will scale automatically. Okay, it's not that you will have 1 million functions running, but you will have quite a few thousands of containers running to run that function. Regarding the DDoS, the DOS is if by any means you want to show off and say, hey, we have 10 million users in a minute, that can reach the limit of invocations. That's the only thing. Again, I've never seen it, but it can happen. So the Lambda functions scale horizontally, but you reach a limit from the vendor.
Hi. Maybe that's a very simple question, but this is a very new topic to me, but maybe we can clarify. So let's say once your request reaches your API gateway, how does your API gateway communicate to the function? Is it also another REST or HTTP request to the function?
That is inside the vendor. I haven't checked that. I know there's an event fired, and inside the event is an object with a bunch of things. One of them is the body of your request. How they do it inside the vendor, I haven't dug that deep.
Okay, and also, can the functions also just communicate directly with each other, just like this function as a service just call the other function as a service, or they always have to go back to the gateway?
They can. In my way, the way you would architect, you wouldn't need that. If you need so function A to run, and then function B and C, for instance, delete the customer. He goes and asks to delete the account. You call function delete account, you change the database, and then you can fire a notification, and all the functions that are listening to that event type, which will then send an object with, in this case, the customer ID or any other data you need, those will run automatically. So you don't need to call one function from the other. The function should be very simple, like create customer. Goes to the database, creates stuff, goes away. If some other things are needed, you can fire an event, a notification, and something is listening to that notification.
Okay, so then the pattern is just like the single side effect, and the other side effects events that might trigger something else.
Yeah, so it's an event-driven application in this case, but all done in the cloud.
Okay, thank you.
Sorry, I'm also new to the topic. I'm just curious, can we also test locally? Is there any problem with that?
You can. There are frameworks. You're talking about the front end or the back end part? Let's still, both.
Both.
front end, yes. You have React, you just start locally and you test locally. If you want to test the functions as a service, you have several frameworks that will help to create them on your host. One of them is serverless.com. And then you can invoke a function locally and test it locally and debug it locally. There are other frameworks like also Claudia.js. I know there are others. Sorry for the others, but I don't remember the names. But been working with serverless.com, very happy with it. So you can run locally, debug locally, and then at the end deploy.